insights into the formation of other solar systems. But how do we even know that this object came from outside the solar system, and not just some rogue Kuiper Belt object? Neil deGrasse Tyson says that it's extremely easy to find out. It's all thanks to the speed of the object. We can tell an object is extraterrestrial if it's going very fast, too fast for it to be contained by the sun's gravity. Oumuamua was traveling at a speed of 196,000 miles per hour when it got close to Earth. Neil deGrasse Tyson. He discussed the peculiarities of Oumuamua's trajectory and the theories proposed by scientists. He mentioned the possibility of another force influencing its movement and cautioned against immediately jumping to the conclusion of aliens. Tyson highlighted the hydrogen iceberg theory, the dust bunny theory, and the recent nitrogen iceberg theory. He emphasized the natural explanations and deviation from the initial extraterrestrial speculations. Neil deGrasse Tyson discussed the peculiarity of not fully understanding Oumuamua's trajectory. He mentioned the possibility of another force influencing its movement. While the idea of ice melting off as Oumuamua neared the sun was proposed, he cautioned against immediately jumping to the conclusion of aliens. The hydrogen iceberg theory suggested in 2020 faced challenges in terms of survivability and formation processes. The theory of Oumuamua being a giant dust bunny originating from a comet outside our solar system was also proposed. However, the recent nitrogen iceberg theory gained traction within the astronomical community. This theory suggests Oumuamua could be a fragment of nitrogen ice that broke off from a distant exoplanet millions of years ago. These findings offer a more natural explanation and deviate from the initial extraterrestrial speculations. Scott Shepard, a researcher not involved in the study, acknowledged the plausibility of Oumuamua being a fragment of an icy dwarf planet. However, the case was not closed yet. The researchers analyzed the behavior of different types of ice composed of hydrogen, nitrogen, and oxygen under similar circumstances. They found that a substantial chunk of nitrogen ice could exhibit similar characteristics to Oumuamua. However, measuring nitrogen gas proved challenging with the available telescopes at the time. The studies also identified potential sources of nitrogen icebergs, such as dwarf planets and celestial objects at the periphery of solar systems like Pluto and Neptune's moon Triton. They proposed that during the early stages of a distant solar system's formation, collisions between planetary bodies occurred, resulting in the detachment of a nitrogen chunk. Over time, this nitrogen iceberg made its way to our corner of the Milky Way. As it approached the Sun, its surfaces eroded, transforming it into a flattened pancake-like shape. However, an opposing argument was presented by Professor Avi Loeb and Amni Siraj. They argued that if objects like Oumuamua were formed entirely of nitrogen split from exoplutos, then there must be a significant amount of exoplutos in our galaxy to account for them. However, the number of exoplutos in our galaxy is calculated to be extremely low. The density of Oumuamua-like objects in our galaxy is also a subject of disagreement among scientists. Some argue that they are less common than anticipated, while others believe they are more abundant. This discrepancy affects the viability of the nitrogen ice theory. More recent studies propose that Oumuamua was a comet unlike any within our solar system. They suggest that cosmic radiation converted a significant portion of a water-rich comet's ice into hydrogen gas, which became trapped within Oumuamua's ice. As it encountered the Sun, the trapped hydrogen gas was released, leading to an unexpected acceleration. While some astronomers find this model convincing, others disagree, claiming that the surface temperature of Oumuamua was miscalculated, leading to inaccuracies in estimating the available hydrogen within the iceberg. The possibility of studying interstellar objects like Oumuamua is exciting. Sky survey technologies like the Pan-SDARS-1 telescope allow us to detect more of these objects. The James Webb Telescope also holds great potential in investigating the chemical compositions of interstellar objects and uncovering valuable insights into their origins and formation processes. There is enthusiasm among some individuals about the prospect of visiting these interstellar interlopers. Plans have been proposed to study these objects as they traverse the solar system, and even to acquire samples from them. The European mission Comet Interceptor aims to wait for an interstellar object to pass through our solar system and study it. The origin of Oumuamua remains a mystery. Initial calculations indicate that it likely originated from the general direction of the star Vega about 300,000 years ago, but further details are uncertain.